David Smith here with one more Flip Classroom math video. 3 tips before we start. First, you can increase or decrease the playback speed if that helps you get through the video. Second, you can pause the video at any time to catch up with your notes. Third, you can turn on the captions to watch my words go by on the bottom of your screen. Today's lesson covers algebraic fraction. And I find that a lot of my 9th and 10th grade math students need a little help with factoring and canceling and simplifying fractions. So we're going to spend the next 3 lessons looking at that. So simplifying algebraic fractions, here's the recipe for that. You might be able to skip this once you see the pattern. But if you struggle with doing this, this is by far the more foolproof way of going. So what we do is we factor the top and the bottom, and then we cancel the common factors. Now, I'm going to illustrate that with a very simple non-algebraic fraction to show you what I mean. So you could pretty easily realize that this is just 3. There are 3 9s in 27, so 27 over 9 is just going to be 3. But I'm going to show you what I mean by factoring and canceling. So 27 is 3 times 3 times 3. 9 is 3 times 3. Now when you factor, you're shooting for a prime factorization. I can't factor this any further. 3 is prime, and the same for the bottom. Now that I've got my prime factorization of top and bottom, I can do some canceling, namely like that. And remember, canceling always happens in pairs. So I've canceled top and bottom of those 2. I have 3 left. There is a 1 down there. So this is going to be 3. So I want you to pause the video and try this one. Factor top and bottom, cancel common terms, and let's see what you got. All right, so this factoring is pretty easy. The only thing I can tease out is the x squared. That becomes x times y, and then on the bottom I have 2 times x. Now I can cancel out a pair of x's. There's 1 each on the top and on the bottom, so I end up with xy over 2. So that's my answer for that one. Now let's take a look at one that's even a little bit more complicated. Go ahead and factor this all the way down, do your canceling, and let's see where you wound up. Okay, I did a fair amount of steps. We're still not at the answer. You have to remember your powers here for the top. This exponent applies both to the 4 and the x. So I ended up with 4 squared, which is 16, and then x squared. So that's my top. On my bottom, my 8's prime factorization is just 2 times 2 times 2. So that's my bottom. That's not going to change until we cancel. Now I have to factor my top. 16 is 2 times 2 times 2 times 2. It's 4 of them. That's what I've written out there. And my x squared becomes x times x. So now I'm going to cancel. I'm going to cancel those 2's, and those 2's. What I have left is 2 times x times x. I can't cancel any of these x's because there's none on the bottom. So this one's just going to end up being 2x squared, like that. Okay, let's do a few more complicated ones where we have addition or subtraction on the top of the equation. It makes the canceling a little bit more challenging. So I'm going to go ahead and do this one, and then we'll take a look. So what this one is, let's go ahead and do our prime factorizations. We got 2 times x plus 2 times 2 times 2 over 2. Now I've got a lot of 2's going on, so it seems like this should be a good one where I can do some canceling. Now the way canceling works is if you have a plus or a minus separating 2 terms, you could still cancel. You just have to cancel it out of both of the terms on the top. Okay? So I can cancel this 2 with this one only because I would also cancel this 2 at the same time. So I'm going to cancel that and that and that. So I'm doing that all at once. Now there's another way to see this. What I could do is I could just write the top as 2 times x plus 4. That's factoring a 2 out of each of these terms, and then that would be also over 2, and I would cancel those 2. Either way gets me to x plus 4. This one would be x plus 2 times 2, which is 4. That goes away, it's a 1, so I have x plus 4. Okay, so a couple ways to think about that. What I'd like you to do is pause the video and try this one. Okay, the trick with this one is to notice that on the top, I have 3x, I have a 3x term in both of these terms. So that means I can factor 3x out of both terms on the top, so I get 3x times x minus 4. And the way I know that worked is if I did my distributive property on this, I'd get back to 3x squared by multiplying those two, that's this term, and then 3x times negative 4 is minus 12x, which gets me back to that one. So I know I did that right. So now I have a 3x and a 3x top and bottom. I can cancel those out, and this one becomes x minus 4. And that's simplified. Now try this one. See what you can get with that one. Okay, so I look at the top here and I realize that there's a 5x in both of those terms. There's a 5x in here, and there's also a 5x in there. So when I factor that 5x out, I have an x minus 7 there. If I did my distributive property here, I get back to that expression, so I'm good. I bring my 5x over. Now I have two 5x's I can cancel, and my result is x minus 7. Let's do 3 more problems, all a little bit more complicated than we've done so far. So take a look at this one. I have 6 times x plus 5 over 3x plus 15. Now there's a certain trick you've got to see to do some canceling and find out what this expression can be reduced down to. Okay, so let me show you the first step. The top is factored. I have 6 times x plus 5. The bottom can be factored. I can pull out a 3 from both terms, and I get, oh, look at that, x plus 5 on the bottom. That's kind of nice. What comes next? See if you can solve that one. This one reduces down to 2, and here's how. My x plus 5s cancel out. They go away. I have 6 over 3, which is 2. Pretty neat. Who'd have thought that this complicated expression would reduce down to 2 and have no x's in it? Okay, pause video and try that one. Okay, so the top is factored. The bottom can be factored into 7 times 2. I can't really do much with the top yet. Now what would come next? I can cancel my 7s. These are all multiplication, so I don't have to worry about canceling from 2 terms. So this would end up being x minus 5 over 2. That's all it would be. Get used to answers that aren't super clean. Like, that's great, it came out to be 2. This one is x minus 5 over 2. Still perfectly fine algebraic expression that we cannot simplify further. Okay, let's try this one. Look it over. I can tell you that the result of this one is 3. Now, it looks like it's really complicated, but actually it's not. You just have to see. There's a big hint in one of these 2 problems that will show you how to get there nice and quick. Give it a shot. Okay, here's the trick. 2x minus 7 is a term that's in top and bottom. They cancel out. I have 6 over 2, which is equal to 3. All day long. Nice and quick. Now that you've watched the video, take a moment to jot down any remaining questions so you can bring them to our next class. Remember, you can also come back to this video again and watch it for deeper understanding. If you liked or enjoyed the video, please click like or subscribe down below.